All right, for 5.7, I split the homework up into two different sections, trig powers and partial fraction decomposition, and I did that for two reasons. The problems are so dissimilar that it really doesn't make sense to group them all together. The only commonality that they have is they both happen to show up in this section of your book. And the other thing is, it takes a little while. They're a little tedious. The partial fraction decomposition is some pretty intense algebra, and the trig problems, I don't know, they can just be kind of rough, especially the sine and cosines raised up to an even power. It just, for me, I felt if I broke them up into two different problems, then you get more extra credit, right? If there's 6 problems, if it's a shorter assignment as opposed to 12, and it only covers one topic, then you do 5 of the 6, you get 100%. And if you do 6 of the 6, well, then you get 20%, because if you do 6 out of 5 correct, you get 120%. That'd be a lot of extra credit for this one. And similarly, on the next assignment, I think there's only 4 problems. So 3 of them are required. You do 4 out of 3, you get 133% on that homework assignment. So it gives you a little bit of incentive, and it's maybe my way of apologizing for teaching you this topic that's a little bit tedious and can take a little while. Without further ado, trig powers. This first question, you see sine raised up to the 8th power, and you kind of groan. You're like, oh no, even powers, that's the worst. But then you come over and you look at cosine, and you see that's only raised to the 3rd power, and you're like, oh, thank goodness. Cosine to the 3rd power, that'll be really easy to deal with. It doesn't matter what power this is to. If this is to the 3rd power, we can do our odd powers trick on this problem, and it should be fairly easy to solve. This second one, similarly, you look over here and you're just hoping you find at least one odd exponent. In this case, you find 2. So you can either peel off one sine and change the rest into cosines, or you can peel off one cosine and change the rest into sines. I think I gave you a hint in the video saying that it'll make your life easier if you use for your du whichever function has the smaller exponent on it. So I think what you're going to want to do is peel off one cosine here and save that for your du. You can do it the other way. It'll just take you longer if you peel off one sine and save that for your du. Question 3, very similar to question 1. Not quite sure why it's on here twice. Maybe there was logic at one point. This should go really smoothly for you. You see an odd exponent here. You see a 3. You're really happy. That's the easiest possible type of problems. Peel off a sine, deal with the rest of the signs, changing them into cosines, and figure out the integral. Question 4, this is actually the 3rd video that I made where we dealt with tangents and secants. One of the 2 examples in that video dealt with exponents that you'll see in your problem, whether they're even or odd. You'll want to reference different videos. I know that I did a problem that'll be very similar to whatever version of question 4 you see on your homework, because what you'll see is the homework system will randomly change these exponents on you, but it's not completely random. It's programmed in there, keep this even or keep this odd or those types of things. Anyways, question 4, reference that 3rd video and you should be in good shape. Questions 5 and 6, these are the miserable ones. The good news is one of them is extra credit, right? You only have to do 5 out of 6 to get 100% on the assignment. So if you want to skip one, you can. In both of them, it's kind of the same idea. You're going to change, you only see even exponents on both the sines and the cosines. That's bad news. And then you're like, all right, sines and cosines are both even. So I'm going to change all of my maybe cosines into sines using the Pythagorean identity. But then I'll have sine to the 4th power. And sine to the 4th power is pretty obnoxious. You have to do 2 different iterations of that double angle formula substitution. Follow that 2nd video. I think you'll see an example very similar to this. It's worth pointing out that in the video, we didn't have a 4x here. We just had an x. If you have trouble with this being a 4x, just do a u substitution in the very first step. Right? Make u 4x or v 4x or something. Pick whatever letter you want. And then at the very end, you can change your variables back into x's. If that 4 gives you trouble, you don't have to do that. Question 6, this is the one that I started in the 2nd video and I didn't even finish it because it becomes so miserable. You change your cosine squared into 1 minus sine squared, but then you multiply sine to the 4th times 1 minus sine squared, and that leaves you with sine to the 4th and sine to the 6th. And the sine to the 4th will be annoying, kind of similar to question 5. The sine to the 6th will just be terrible, very similar to the video that I did. I'll leave it up to you whether you want to take the time to go through and actually solve this one. I'm not going to lie, it's going to take you a little while, but maybe it's good practice. Good practice with all the algebra and the different trig identities, and I did at least get you started on it in those videos. And that's this homework.